There's this hidden flaw deep inside our modern world. It's a fundamental inefficiency that we interact with every single day, and it costs us trillions of dollars. It happens every time you flip a switch, charge your phone, and solving it could change, well, everything.
So get this, up to 10% of all the electricity we generate is just lost. It vanishes into thin air before it ever gets to us. That is a staggering amount of waste. Think about that for a second. It's like there's a massive invisible tax on every single watt of power we create.
So what is this invisible energy thief? What's causing this massive loss? Well, the culprit has a name you probably remember from high school physics class: electrical resistance. The best way to think about resistance is like invisible friction, right? Just like friction on a road slows down your car, electrical resistance slows down the flow of electricity inside a wire. And all that energy has to go somewhere. It escapes as heat. It's the reason your phone charger gets warm. That heat, that is pure wasted power.
So for over a century now, scientists and engineers have been chasing this dream. I mean, what if we could eliminate that friction completely? What if we could have a wire that was perfectly efficient?
That dream has a name. It's called superconductivity. And the concept is just beautiful in its simplicity. It's a state where a material has absolutely zero electrical resistance, zero friction, which means zero energy loss. Every bit of power that goes in one end comes out the other. It's perfect efficiency.
And the difference is just incredible. A normal wire has resistance. It loses energy. A superconducting wire has zero of both. But, and you knew there had to be a but, right? It's a huge one. To get this magical state to work, current superconductors have to be cooled to near absolute zero. We're talking colder than deep space.
So that's the whole problem right there. The tech exists, but it needs these gigantic, super expensive cooling systems to work. It's why you only see this stuff in, giant MRI machines or particle accelerators. It's just not practical for the real world. At least, not yet.
So let's imagine a breakthrough, a material that unlocks this dream for all of us without any of that crazy cooling. The race is on to find this material, but for our explainer today, let's give this hypothetical invention a name. Let's call it Arctis 25. Arctis 25 is basically the holy grail of material science, a room-temperature superconductor. It's a material that could carry electricity with perfect, flawless efficiency, right here at normal temperatures. This isn't just an improvement, this is a total game changer. It rewrites the rules of energy.
The impact of something like Arctis 25 wouldn't be small. We're not just talking about saving that 10% of lost energy. We are talking about a full-blown revolution, one that would completely rebuild our world on 4 foundational pillars.
And those 4 pillars are a global supergrid, perfect energy storage, hyper-efficient transportation, and finally, making fusion power a reality. So let's break down how each one of these would completely change our world, starting with the grid. First up, the supergrid. Our electrical grid today is, well, it's kind of leaky and it's really limited by distance. But with a wire that has zero loss, distance becomes totally irrelevant. I mean, really think about this. You could build enormous solar farms in the Sahara Desert and send that clean energy to power all of Europe with absolutely zero loss. You could harness cheap hydropower on one continent and use it on another. Suddenly, the best place on Earth for wind or solar becomes a resource for the entire planet, not just for the people who live nearby. Okay, next up, perfect energy storage. This technology would solve the single biggest problem with renewables, right? Their Achilles heel. The sun doesn't always shine and the wind doesn't always blow. We need a way to store that power perfectly.
A room-temperature superconductor makes something called superconducting magnetic energy storage, or SMES, a reality. It lets you store massive amounts of electricity in a magnetic field, indefinitely, with no loss, no degradation over time. And when you need that power, it's released instantly. This is what makes solar and wind power reliable, 24/7 energy sources.
The third pillar is a complete revolution in how we move. Because that same energy-wasting friction, it's not just in power lines, it's happening inside every single electric motor on the planet.
Imagine electric motors that are nearly 100% efficient. In our cars, in ships, even airplanes. They wouldn't generate any waste heat, and they'd barely need any maintenance. And on a bigger scale, this makes those sci-fi Maglev trains, the ones that float, not just possible but practical and affordable on a global scale.
And that brings us to the final and maybe the most profound pillar of them all, unlocking the ultimate source of clean energy.
You see, fusion energy,
Basically, creating a tiny star here on Earth depends on containing superhot plasma with incredibly powerful magnets. Right now, those are superconducting magnets that need, you guessed it, massive, expensive cooling. By getting rid of that requirement, a material like Arctis-25 could be the missing piece of the puzzle that makes near-limitless clean fusion energy a reality.
So, when you take all four of those pillars and you put them together, what does this new world even look like? It's not just a more efficient world, it's an entirely new era for humanity.
This really captures the scale of it. This kind of invention doesn't just save us money, it dismantles the very limitations that have defined our energy systems since the days of Edison. It's about fixing the one fundamental flaw that's been there from the very beginning of the electrical age.
The end result will be an era of abundant, clean, pollution-free power, an era where energy scarcity is a concept from the history books. This would completely reshape our economies, our geopolitics, and maybe most importantly, our relationship with the planet, creating a truly sustainable future.
Now look, while Arctis-25 might still be hypothetical, the global race to find a true room-temperature superconductor is very, very real. And it makes you wonder, what other breakthroughs are just around the corner? So I'll leave you with this. What invention do you think has the power to change the world forever?